Welcome to KringleCon 3 French Hens. My name is Dave Herrald. I'm a principal security strategist at Splunk, and we're very happy to be here today at KringleCon to talk to you about adversary emulation and automation. A bit about my background. I've been in security and technology for quite a long time now. I've had many different security roles, everything from running security programs as an information security officer to being a security architect, security engineer, security analyst. And I've had lots of roles in IT as well, mostly around infrastructure, system administration, and network engineering. I'm a former SANS mentor, and I've really been a product of SANS in my career. I'm a GSE. I have a lot of SANS certifications. I've spoken at a number of SANS summits over the past few years with my colleague Ryan Kovar. Currently in security, I'm focusing on adversary emulation, which is the subject of this talk, cloud security, and I've been doing a lot of full stack development and getting into DevSecOps more in my day job at Splunk. I've been at Splunk for about 6 years, and I'm the co-creator of the Splunk Boss of the SOC. As I said, we're very appreciative of the opportunity to be able to participate in KringleCon and in Holiday Hack Challenge. There's a great deal of trust that's been placed in us by SANS and by Ed and by the folks at CounterHack, and we take that very seriously. At every turn, we will seek to emphasize security and best practices, and we will not emphasize product positioning in these challenges. With that said, we do use Splunk in these challenges, and it's because that's what we have access to. But most of these concepts are universal and could be applied to really any technology stack that you have in your SOC. So please keep that in mind as we proceed. Why should we emulate the adversary? Well, number one, it allows us to build better detections. One of the primary activities that you engage in as a blue teamer protecting an organization is to create detections that can raise alerts when evidence of adversary activity is detected. In order to do that, and in order to improve those detections over time, you need a source of telemetry, a source of data that represents the adversary's activities. A great way to get that is through emulation. While it's certainly not the only way to get that data, it does offer some benefits, especially consistency and repeatability. The next reason is that emulation allows you to test your detections. Security detections are actually quite fragile. They're subject to many externalities that can cause them to stop working. The most successful organizations treat their detections like code, and they test them with a CI/CD pipeline. In order to do that, you need repeatability, you need consistency, and adversary emulation offers that. The third reason is that it allows you to test your vendors' claims about their products. Every security team has dozens, if not hundreds, of different tools in their SOC tool chain. Each one of those tools claims to provide certain value to your organization, but it becomes very, very useful to be able to emulate adversary activity in a realistic way and then test whether those solutions can actually detect that activity. We have seen a dramatic increase over the last year to 18 months of customers demanding that we emulate the adversary and then show that our products can detect that. It's an extremely effective tactic to use when dealing with vendors or when testing one vendor solution versus another. If you'd like to dig a little bit deeper into reasons why you should include adversary simulation in your security program, you might want to check out some of these resources. Over the past couple years, some colleagues of mine and I have been working on an adversary simulation project, and we've presented on that at a number of conferences, some Splunk user conferences, a SANS Blue Team Summit, and also Black Hat Arsenal, both USA and Asia in 2020. I do recommend checking these out. They give a little deeper treatment to why you might want to do adversary simulation. But for today, we're going to continue on and show you exactly how to start simulating the adversary. So I want to show you one way that you can get started with adversary emulation. It's really broken down into 4 easy components or steps. The first one is Splunk attack range. Second is the MITRE attack framework. Third is the Atomic Red Team project from Red Canary. And fourth is Splunk. Splunk attack range, number 1 on this list, is a really cool project. It's free, it's open source, it's created by some really smart people at Splunk, and it makes it really easy to spin up a range and then to launch attacks in that range and then look at the results in Splunk. The MITRE attack framework, of course, is the basis of a lot of security content these days. It's a knowledge base of adversarial activities, and it's free to use published by MITRE. It's an amazing resource. Most security content these days has some sort of a mapping to the MITRE attack framework. The third item on this list, Atomic Red Team, is also free. It's an open source project. It's created by Red Canary, an amazing company who contributes so much to the open source community. The fourth on this list is Splunk. Splunk has some forms in which it is free. It's free-ish. Certainly for everything we're going to show you in this talk today and in anything that you'll see at KringleCon or in the Holiday Hack Challenge, you can do that with the free version of Splunk. And in fact, the Splunk attack range, item number 1, provides Splunk for free. It spins up a Splunk instance running with the free license. The bottom line is you can employ this flavor of adversary emulation for free. Now you might accumulate a bit of cloud infrastructure as a service costs to spin up systems, but there's no software licensing fees involved. So let's talk about the Splunk attack range. As we mentioned on the last slide, Splunk attack range is a free open source project. You can check it out at the URL listed on the bottom of this slide. Attack range is a Python script and a set of configurations for Terraform and Ansible that allow you to set up ranges in cloud services like AWS and Azure. You can actually use attack range to set up ranges locally on systems as well. However, we'll only talk about the cloud options today. The ranges include an Active Directory server. They can include Windows servers, they can include Windows clients, they can include Linux machines. The Windows systems are configured with sysmon. They're configured with an appropriate logging policy for Windows security events. You can include OS Query. You can include Caldera and Atomic Red Team. We'll talk a lot about Atomic Red Team today. You can include things like Splunk Stream, the Splunk Universal Forwarder, which is the agent that sends logs from systems to Splunk. You can also include MITRE Caldera. You can include, of course, Splunk and Splunk Phantom and even Kali Linux. And this is all driven by the configuration that you choose. One thing that is of note is if you see at the bottom of this slide where it says index equals win, index equals attack, index equals main. These are the places within Splunk that you are going to see the events that are generated by our adversary emulation. It's important when you get into the Holiday Hack Challenge that you pay special attention to what index you're searching in Splunk. I'd like to call out the authors of Splunk Attack Range, Jose Hernandez and Patrick Barris. Jose and Patrick are colleagues of mine and good friends of mine. They go to great lengths to publish the Splunk Attack Range, to quickly address bugs and constantly add new features to it. They also go to a great amount of effort to ensure that Attack Range remains an open source project. Not an easy thing to do at a commercial software company. I applaud them for their efforts, and I love collaborating with these two gentlemen and the entire Splunk threat research team. Let's take a couple minutes to talk about MITRE ATT&CK. MITRE ATT&CK is widely covered in information security. You very likely have heard about MITRE ATT&CK and know a lot about it already, so we'll just hit the high points. MITRE ATT&CK is a knowledge base of adversary techniques. As such, it's very useful to search through the MITRE ATT&CK website when you have a question about things like adversary simulation. That's something to keep in mind when you are working through Holiday Hack Challenge. MITRE ATT&CK is organized into tactics. Tactics often describe why an adversary might perpetrate a certain type of attack. Techniques are how they will perpetrate that attack. And techniques, as of fairly recently, can be divided often into sub-techniques, which allows another dimension to more richly describe adversary techniques. You often see MITRE ATT&CK expressed as a matrix. This is the MITRE ATT&CK Enterprise matrix. And you can see here that the columns are those tactics that we mentioned on the last slide. Now, under those tactics are techniques. And in fact, if you click on one of these techniques, you'd see a great deal of detail, including, but not limited to, these sub-techniques. You can see there's 12 sub-techniques here. Now, this one is ID 1547, or I should say ID T1547. T is for technique. And boot or logon auto start execution is a big technique. It's been used a great deal over the years, and that really is reflected in the number of sub-techniques. Now, also notice that this technique is pertinent to Linux platform, Windows platform, Mac OS platform, and probably every operating system that's ever existed in the history of operating systems. And so you need a lot of sub-techniques to show all the different ways that you could attack these various different operating systems. Another thing that you'll notice here, if you look at a particular technique, is you'll find a great deal of historical research that's been performed. So really any time that this technique has been used in a breach or a compromise or a prominent attack, and there's been public information published about that, you'll find that reflected here. There's a great deal of threat intelligence that goes into the MITRE ATT&CK, and that's one of the most valuable parts of MITRE ATT&CK, is to understand when these techniques have been used and to what adversary groups these techniques have been attributed in the past. So let's talk about item number 3 on our list for adversary emulation, and that is Atomic Red Team. Atomic Red Team is an open source project. It is free, it's published on GitHub, and it was created by a company called Red Canary, and Red Canary continues to maintain Atomic Red Team. If you're not familiar with Red Canary, they're one of the most prolific contributors to the security community that you'll ever find. Just an amazing company, a really open group of people who are really dedicated to sort of helping the community. They're also a commercial company. You can check out their commercial offerings as well. But just a really big fan of Red Canary. Let's talk about what Atomic Red Team brings to us in terms of adversary emulation. So this is looking at the Atomic Red Team project on GitHub. Its organization mirrors the organization of MITRE ATT&CK itself. In this case, we're looking at T1547. That's the same technique we looked at earlier when we were looking at MITRE ATT&CK. But where Atomic Red Team comes in is it picks up where MITRE ATT&CK stops. And where MITRE ATT&CK will describe a certain technique in quite a bit of detail, it stops short of giving us something that we can actually execute. So it does not give us source code for a malicious program. It does not give us a command line that an attacker might run. And that's where Atomic Red Team comes in. Atomic Red Team provides just that. They call them atomics. And atomics are the actual code for a particular operating system or a particular environment that you would run to implement a technique. And so when we're trying to do adversary simulation, Atomic Red Team fills a big void. It gives us a very large library of techniques that we can emulate at will because we have very specific atomic tests defined. So let's talk about our fourth and final component of our adversary emulation recipe that we're creating. Now recall that we're using attack range to spin up some target infrastructure in the cloud. We're selecting some techniques from MITRE ATT&CK, and we're instructing attack range to run atomic tests from Atomic Red Team that are aligned with our techniques from MITRE ATT&CK and running those against that cloud infrastructure. Now the result of that will be telemetry. It will be logs and other types of events that will be stored in Splunk as a result of executing these emulations. Now for convenience, the way we've organized this is that all the results from a particular technique are stored in their own index. So you can see here in the Splunk search window, we're specifying index equals T1547 star. Star is a wildcard. There's actually multiple indexes for some of these techniques, but they all begin with the technique ID. Now you'll find some also that have a technique ID followed by a dot and then a sub-technique ID. And so watch out for those as well. Now, beyond specifying the index as we're showing here, you can run all sorts of Splunk search commands. Any other field that you want to search on, you can simply place after that index equals T and then the technique ID. I want to show you a couple of more important things that you'll need to keep in mind as you're searching through Splunk. One is that you want this time picker to be set to all time. Don't set it to something shorter than that, like last 24 hours or last 4 hours, because this data was collected a few weeks ago. Set it to all time. It's important though to remember that if you go back to your production Splunk instance at your day job, don't run searches for all time because they're typically not going to be very performant and they typically will consume a lot of resources, and then your Splunk admin will be upset at you and probably at me. So use all time here in Holiday Hack Challenge, but don't use that when you are searching in your production Splunk instance. You should also use smart mode as indicated here. Once in a while, this will get set to something called fast mode. You typically don't want that, so just make sure that that is in smart mode. Another piece of advice that I'll give you is to watch the KringleCon 2 video from Splunk. It's called Dashing Through the Logs. It's from 2019. It was written and presented by James Brodsky of Splunk. There's loads of good recommendations in there about how to be more effective at searching Splunk and how to traverse through security-related source types inside Splunk. So wealth of knowledge there. We didn't want to repeat it, but if you feel like you need a little bit more background on how to search in Splunk, I definitely recommend that you check out this talk. And this might be the most important slide that you want to take note of if you're preparing for the Splunk challenge within Holiday Hack Challenge 2020. Stay frosty. Thank you so much. Please do reach out on Twitter if you have any questions or if you want to get any more information on adversary emulation. I'm at Dave Herrald, and we look forward to you participating in KringleCon and Holiday Hack Challenge.
Ho, 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 ho.